Hi there, welcome back to the channel. We'll now start with our analysis of oligopoly behavior using the most widely accepted tool, which the economists and mathematicians have referred to as the game theory. So let's start our example with two firms selling burgers. Now, both these firms have a decision to make here. They must decide whether to charge $10 for their meal or $5. Now remember, in an oligopoly market, the decision of firm A will impact the decision of firm B. And likewise, there will be a reaction from firm B to every strategy that firm A follows. So as you can see in this matrix, firm B can either charge $10 or $5. Likewise, firm A can either charge $10 or $5 for its meal. What this table would indicate is the level of profit which either of these firms would enjoy when they price their meal at $10 or $5. So let me add some numbers to each of these boxes in the table. These numbers would indicate the economic profits which each firm would enjoy at different levels of pricing. So let me start from here. Suppose firm A and firm B both price their meal at $10. In that case, firm A would enjoy an economic profit of say 10 million. So I put 10 million here. And firm B would enjoy an economic profit of 10 million as well. So if both the firms price their meal at $10, they would split the market and earn an equal profit of 10 million each. Now suppose firm A wants to increase the sales and hence prices its meal at $5 instead of $10. How would this affect the market and the level of profits enjoyed by both the firms? Let's assume that firm A prices its meal at $5 and firm B remains at $10. Naturally, according to the law of demand, the sales of firm A will rise and profits would rise to say around 15 million. So I put 15 million here. And the profits of firm B, say it falls to 5 million. So I put 5 million here. Now let's look at this part of the matrix. What if firm A maintains its price at $10 but firm B lowers its price to $5? In this case, the sales for firm B would rise and hence the economic profits would rise to say around 15 million. So I should put 15 million here. Likewise, for firm A with such a high price as $10, the economic profits may fall to say $5 million. Finally, suppose both firm A and firm B reduce their price to $5. Now, in this case, neither of the firms would grab a larger market share and they would divide the economic profits to say around 7 million each. So I put 7 million here and 7 million here. So let me highlight these profits. So all of these highlighted profits indicate the profits of firm A based on the prices of firm B, which is its competitor. Likewise, the non-highlighted numbers indicate the payoffs or profits of firm B, which is dependent on the pricing strategies of firm A. So essentially, this payoff matrix indicates all the combinations of economic profits arising from the action of two competitors, firm A and firm B, in an oligopolistic market. Now, carefully look at this table and try to analyze the most likely outcome of this strategic game, where firm A and firm B have to decide between a lower price of $5 or a higher price of $10. So let's start from this section. Suppose currently both the firms are selling their burgers for $10 and both of them are enjoying a very high economic profit level of 10 million each. We also saw in this section that firm A has an incentive to lower its prices since there is a possibility of a higher economic profit of 15 million. So we can say that this pricing strategy is the best interest of firm A. But this has a negative impact on firm B because consumers would now switch for firm A, thereby reducing the profits of firm B to 5 million. So this is not a favorable outcome for firm B. Now let's look at this possibility. When firm B lowers its price to $5 and firm A maintains its price at $10, firm A is very likely to see a decline in profits from 10 million to a bare $5 million. So this is definitely not an optimal pricing strategy for firm A. On the other hand, firm B would enjoy a higher economic profit of 15 million. So finally, if both the firms match the price decrease and both of them sell their burgers at $5, then the economic profits for both the firms would go down from 10 million to 7 million. In this case, neither of the firms would be able to grab a higher market share. Now let's try to analyze the pricing strategy. Suppose firm A sells its burgers at $10. What should the firm B do? So firm B should sell at $5 because this would help the firm B to generate a higher profit. If firm B sells at $10, then the profit would be 10 million, but if it sells at $5, the profit would be 15 million. So definitely selling at $5 would be the best optimal strategy for firm B. Likewise, what if the firm A sells at $5? So in this case, if firm B sells at $10, then it would be earning 5 million. On the other hand, if firm B sells at $5, it would be earning 7 million. So definitely it is in the best interest of firm B to sell at $5 even in this case. So we saw that in any case, whatever be the strategy of firm A, firm B should always sell at $5, and hence we can say that $5 is a dominant pricing strategy for firm B. So in game theory, the dominant strategy is the course of action taken by a firm regardless of what its competitor does, and this is a winning situation for the firm in any case. So we saw here that when firm A sold at $10, firm B sold at $5. Similarly, when firm A sold at $5, firm B again sold at $5. So selling at $5 is the dominant pricing strategy for firm B. And since the payoffs for firm A is the same as firm B, and assuming that both the firms have the same cost structure, we can say that $5 is a dominant pricing strategy for firm A as well. So this is the most favorable outcome of this pricing game where both the firms have a winning situation. And as for the consumers, the price of burgers in the market would always be $5. Any increase in price is automatically regulated by competitor actions, and hence the market equilibrium price is set to $5. What is the implication of this? The implication of this is that in an oligopoly market, without the possibility of collusion, the economic profits for both the firms will always be reduced and they will always end up charging a lower price for their product. This indicates a very high interdependence of firms on each other. However, this model assumes that both the firms have the same cost structure. If either of the firms build up on their technology and achieve a lower marginal cost and better economies of scale, then the payoffs for each firm would be different. In that case, the dominant strategy for both the firms would change based on the revised payoff matrix and their respective economic profits. So let's move on with our discussion and look at an example where the payoff matrix shows different economic profits for firms. So in this case, as you can see here, we have two technology firms, A Tech and B Tech, and each firm can choose to have a high price or a low price for its product. And the payoff matrix that you can see here, it shows the estimated profits for both the firms. Now notice that the payoff matrix shows different profits for A Tech and B Tech. And given this situation, let's try to analyze the pricing strategy. Now we need to figure out what is the dominant strategy for both the firms. Now we know that a dominant strategy is a strategy which is the most optimal choice for the firm, regardless of what strategy the other firm follows. For example, if the dominant strategy is setting a low price, the firm would continue to set a low price irrespective of what price its rivals charge. So take a pause and try to figure out what the dominant strategy for both the firms would be. All right, let's take the situation of firm A Tech. Suppose B Tech chooses to go high. So we are in this part of the matrix. Now you can see that when B Tech chooses to go high, then it is optimal for A Tech to charge a lower price because the earnings are maximum when the firm A chooses to go low. So when B Tech goes high, what should A Tech do? A Tech should go low. Now, what would happen if B Tech charged a lower price? So, B Tech is charging a lower price. So, we are now in this part of the matrix. So, A Tech has two options now. Either it can go high and earn a profit of $40, which has reduced because it has lost out its market share to B Tech, or it could charge a lower price and earn a higher profit of $75. So, which is the best optimal strategy for A Tech? Obviously, firm A Tech should charge a low price because that would fetch a higher economic profit of $75. So, let me write that down. When B Tech goes low, A Tech should also go low. So we saw that in this case, no matter what B Tech does, it makes sense for A Tech to charge a lower price. So the dominant strategy for A Tech is to go low. So dominant strategy for A Tech is to charge a lower price. Now let's talk about firm B. Now, what happens if A Tech goes high? So now we are in this part of the matrix where A Tech chooses a high price for its product. So in this case, B Tech has an option to earn $110 or $130. So obviously, if A Tech goes high, it is optimal for B Tech to go low. So let me write that down. So when A Tech goes high, B Tech should go low. Now, what if A Tech charges a lower price? So now we are in this part of the matrix. So we can see that in this case, B Tech could either earn $80 or $70. And definitely the optimal strategy for B Tech in this case would be to charge high. So when A Tech goes low, B Tech would go high. So we can see that in this case, there is no dominant strategy for B Tech because they cannot always go low or always go high irrespective of what A Tech does. So the actions of B Tech is highly dependent on the pricing strategy of A Tech. If the two firms do not collude, what would be the profit for each firm? Now, if both the firms do not collude, then A Tech would always charge a lower price since that is its dominant strategy. So the profits for A Tech would always lie in this part of the matrix. Now we know that if A Tech goes low, then B Tech would go high. So if A Tech goes low, B Tech would charge a higher price. So B Tech should be here. So this is B Tech. It charges a higher price. So B Tech should always be here. So the profit for A Tech would be $120. So profit for A Tech would be $120. And since A Tech would always charge a lower price, that being its dominant strategy, B Tech would always be in this part of the matrix. So the profit for B Tech, profit for B Tech would always be $80. And this is a Nash equilibrium. This is because all by itself, no firm can change its pricing strategy unless some external factors like economic slowdown, government regulations, etc. come into effect. So both the firms would stay in this part of the payoff matrix. Suppose the government decides to offer a tax reduction, thereby increasing the economic profits by $20 to any firm that offers to lower its prices. So if the firm has to enjoy the benefits of tax reduction, then it should offer its product at a lower price. Redraw the payoff matrix under this scenario. Now, if the government reduces taxes, definitely the payoff matrix would change for both the firms. So now let's take the case when both the firms offer their products at a higher price. So when the firm offers the product at a higher price, then the firm will not be able to enjoy the benefits of tax reduction. So the payoffs would remain as it is. So if I take this part of the matrix, the payoffs will not change because both A Tech and B Tech offer their products at a higher price. So let me write the payoffs as it is. So this would remain at $105 and this would remain at $110. Now let me consider this part of the matrix. So in this case, we can see that A Tech offers its product at a lower price and hence it can enjoy the benefits of tax reduction, which is an increase in economic profits by $20. So now the payoff for A Tech would be $140. But on the other hand, since B Tech is still at a high, the payoffs for B Tech would not change. So this would remain at $80. Now let's come to this part of the matrix. So in this case, we know that B Tech is offering its product at a lower price. So therefore, it can enjoy the benefits of tax reduction. So the economic profits would increase by $20. So in this case, the economic profit would be 130 plus 20, that is 150. But on the other hand, A Tech is still at high. So A Tech in this area of the matrix would not be able to enjoy the benefits of tax reduction. So the payoffs for A Tech would not change. Now coming to this part of the matrix, in this case, both A Tech and B Tech offer their products at low price. So both the economic profits would increase by $20. So in this case, it will be 75 plus 20, that is $95. And in this case, 70 plus 20 would be $90. Using the revised matrix, what would be the dominant strategy for both the firms? Now, given this revised payoff matrix, let's try to find the dominant strategy. To find the dominant strategy, we just repeat the analysis that we did earlier. So let's take the case when firm B Tech goes high. So if B Tech goes high, then I'm here. Now, in this case, if firm A also goes high, then it earns $105. But if it goes low, then it earns $140. So charging a lower price is the best strategy for firm A Tech. So let me write that down. When B Tech is high, then the best strategy for A Tech would be to go low. Likewise, what happens when firm B Tech goes low? So when B Tech goes low, I'm in this part of the matrix. So what should firm A Tech do? Either it can charge a high price and earn $40, or it can charge a lower price and earn $95. So definitely it is in the best interest of ATEC to go low because it can earn a higher profit of $95. So let me write that down. When BTEC goes low, ATEC should also go low. So in any case, it is most optimal for the firm ATEC to go low. So charging a low price is a dominant strategy for firm A. Now what should firm BTEC do? Suppose firm A goes low. So now I am in this part of the matrix. So if firm A tech goes low, then B tech can either go high or low. If it goes high, then the profit is $80. But if it goes low, the profit is $90. So definitely in this case, B tech should go low. So let me write that down. When firm A tech is low, B tech should also go low. Now what happens if firm A tech goes high? So which means firm A tech is now, so we are in this part of the matrix. So if firm A tech goes high, B tech can either go high or low. If B tech goes high, then it earns 110, and if it goes low, it earns 150. So obviously the most optimal strategy for firm B tech is again to charge a low price. So when A tech is high, B tech should always go low. So you can see that after the government incentive, both the firms now have a dominant strategy to charge lower prices. So both the firms would remain in this area. So firm A tech as well as firm B tech would charge a lower price. So both the firms would remain here, and thus the Nash equilibrium is attained in this part of the matrix. How does the tax reduction scheme affect the profits of both the firms? Would they increase or decrease or remain the same? So we saw that we are in this part of the matrix, and this is where the Nash equilibrium is attained, where both firms A tech and B tech charge a low price for their products because that is the dominant strategy for A tech as well as B tech. So before the tax incentive, what was the profit of firm A tech? We had worked it out to be $120. So before tax reduction, firm A tech was earning $120. Now, after the tax reduction, the dominant strategy for firm A tech is to go low. So in this case, it will earn $95. So after tax reduction, the earnings have reduced to $95. So what happens to the profits for A tech? It has actually reduced because of the government incentive. What about the firm B tech? Before the government incentive, B tech was earning $80 since it was charging a higher price for its product. Now B tech is charging a lower price, so it would earn $90. So after the government incentive, the earnings for BTech has actually increased from $80 to $90. So in this case, there is an increase in profit by $10. So the government incentive has actually worked in favor of BTech, and that's the solution for this case study.